When traveling to a new area in your car, road signs and road maps help you get to your destination. In the same manner, aeronautical charts guide you in the air when you leave your local area. The charts you'll be using for navigation represent the Earth's surface, and throughout your training and flying career, you will be required to locate and identify certain positions on the chart. You can do this by using lines of latitude, which are parallel to the Earth's equator, and lines of longitude, which run from the North Pole to the South Pole. Using the equator as a starting point, we can plot lines of latitude north and south from 0 degrees at the equator to 90 degrees at the poles. By international agreement, the starting point, or 0 degrees longitude, runs through Greenwich, England. The 0 degree line is called the prime meridian. All other lines of longitude are plotted in degrees east and west through 180 degrees. Each degree of latitude is divided into 60 equal segments called minutes, and each tick mark represents 1 minute. Degrees of longitude are also marked in the same way. By using these degrees and minutes, you can identify a position anywhere on the chart. For example, if you were located at the Mentone Airport, you could determine its coordinates by first locating the nearest latitude line, which is 41 degrees. Then count the number of minutes up from 41. In this case, it is 9 minutes. Since latitude increases as you go north in the northern hemisphere, you must add the 9 minutes to 41 degrees. You can also do the same for longitude. Since longitude increases as you go west in the United States, you must add about 4 minutes to 86 degrees. Your geographic coordinates are 41 degrees, 9 minutes north latitude, and 86 degrees, 4 minutes west longitude. Notice that the latitude is always given first when stating coordinates. In addition, you can use minutes of latitude to measure distance. Each minute is equal to 1 nautical mile. For example, to measure the distance between Mentone Airport and Fulton County Airport at Rochester, you can use the latitude lines. The distance is 8 nautical miles. You can verify this by using the nautical mile scale on the chart. Make sure you don't measure distances using minutes of longitude, because those distances will vary depending upon their position with respect to the poles. There are many problems associated with trying to portray a spherical object, such as the Earth, in chart form. When we try to flatten any spherical object, distortions occur. Over the years, several charting techniques called projections have been developed to minimize these distortions and inaccuracies. One method is the Lambert conformal conic projection, which makes a sectional cut through the globe. This projection is used for the 3 charts you will use most during your VFR flying. These include the World Aeronautical Chart, the Sectional Chart, and the VFR Terminal Area Chart. Since the scale on a World Aeronautical Chart, or WAC chart, is 1 to 1 million, it covers the most area. A 1 to 1 million scale means that each inch on the chart represents 1 million inches, or approximately 14 nautical miles on the actual surface. The sectional chart is the most widely used chart. It gives you more detail than the WAC chart, since its scale is 1 to 500,000. Therefore, 1 inch on the chart represents about 7 nautical miles. A VFR terminal area chart provides the most detail. Its scale is 1 to 250,000 and covers a selected terminal area. It provides you with a detailed portrayal of the area surrounding a major airport. Since all three of these VFR charts provide basically the same information, you can become familiar with them by studying just one. In this case, we'll use a sectional chart. The front panel of each sectional has a chart index, and the shaded block depicts the area that is covered by the chart. Sectionals are named for the major city that lies within the coverage area. For example, this is the Albuquerque sectional. Sectional charts show the locations where terminal area charts can be found by outlining the region with a magenta square. Below the U.S. chart index, you can find information on chart elevation. The color bar gives you a graphic description of elevation changes. The highest terrain elevation on the sectional is printed at the top of the color bar, as well as to the left. Its geographic coordinates are also given. Within each area enclosed by lines of latitude and longitude is a distinct number showing the maximum elevation figure, or MEF, in thousands and hundreds of feet. In this case, the 60 represents 6,000 feet. The MEF is the highest known feature in each quadrangle, including terrain and obstructions. An explanation of the MEF is usually found on or near the front panel. General terrain elevation above sea level can be determined by referring to the contour lines on the chart. These lines connect points of equal terrain elevation. This model shows the relationship between the terrain shape and the contour lines shown on the chart. From a side view, you can see that the lines parallel the base at regular intervals. From a higher angle, notice that the lines follow the irregularities of the slopes, valleys, and cuts of the mountains. A top view of the lines is representative of what you will see on the chart. Intervals between contour lines for a particular chart are shown on the front panel. Now let's look at how to interpret the information on the chart. As you unfold the map, you will notice the legend on the back panel. At the top of each panel are the words North and South, indicating the chart coverage area is divided into North and South regions, with each one displayed on a different side. Now we'll examine some of the more common symbols found on the chart legend. Of primary importance are the airport symbols. A blue symbol indicates an airport with a control tower, while a magenta-colored symbol shows an airport without a tower. Airport symbols are shown in a variety of shapes. Runway diagrams shown inside a colored circle indicate the runways are hard-surfaced and range in length from 1,500 to 8,069 feet. When an airport diagram is not in a colored circle, it indicates that at least one of the hard-surfaced runways is longer than 8,069 feet. Near the airport diagram, you will find the name of the airport and information about its facilities. This is the University of Illinois Willard Airport. The abbreviation after the airport name is its three-letter identifier. CT indicates there is a control tower at the field, and it has a primary frequency of 120.4. The star means that the tower does not operate continuously. The C symbol in the filled-in circle indicates that you should use the tower frequency as the Common Traffic Advisory Frequency, or CTAF, when the tower is not operating. The C symbol is also used to show the CTAF at the airport without a tower. In this example, the CTAF is the Unicom frequency. The RP27 symbol is used to specify a right-hand traffic pattern for runway 27. ATIS, or ATIS, stands for Automatic Terminal Information Service, which is broadcast on a VHF frequency of 124.85. This pre-recorded message will give you vital information on airport conditions. 754 is the elevation of the airport in feet. The L indicates runway lighting, and the star tells you that lighting limitations exist. In this case, you should refer to the airport facility directory for more information. The next number, 81, is the length of the longest runway in hundreds of feet. Here, the longest runway is 8,100 feet. However, the usable length may be less. 122.95 is the Unicom frequency. At airports where a flight service station is located on the field, the letters FSS are included above the airport name. Another vital block of information you will be interested in is the navigational aid. The Nav Aid box contains the name of the facility, frequencies, and the Morse code identifier. The flight service station providing voice communication is sometimes identified below the box. In this case, it's the Roswell FSS. Notice that the VHF radio frequencies are colored blue, while low and medium frequency nav aids are shown in magenta. An underline means that there is no voice communication available on this frequency. A circled H, T, or A in the upper right-hand corner of the information box indicates that specific weather information is available from this nav aid. The H in this case means HIWAS is available. Additional information found on the chart concerns obstructions. Let's take a look at some of the common symbols. One is for obstacles less than 1,000 feet AGL. And another symbol is for obstacles 1,000 feet AGL and above. Printed next to the symbol is the height of the structure above sea level. In parentheses is its height above the ground. If the structure has high intensity lighting, the lighting symbol is included. In addition to towers, which can be identified on the chart, roads and highways make good landmarks for navigation. They are indicated by solid gray lines. Divided highways are shown by double lines. Primary and secondary roads are illustrated by single gray lines. The lines for primary roads are slightly thicker than those for secondary roads. Railroad tracks also make excellent visual aids. Another good reference to use while flying is an industrial plant. Large stacks sometimes produce smoke or steam, which is easily visible from the air. You can often spot the smoke many miles before you actually see the plant. Cities make good checkpoints. Cities and larger towns are shown on sectionals in yellow, which defines the built-up area. Smaller towns, on the other hand, are only represented by a circle on the map. Since you can't identify the towns by their shape, you must use other landmarks to prevent mistaking similar-looking towns, especially those close to each other. Besides highways and railroad tracks, some of these landmarks are racetracks, outdoor theaters, and bridges. Terrain features can also help you identify your location. Reservoirs and lakes are shown by an outline representing the approximate layout of the body of water. A blue line on a chart represents a river. The wider the line, the wider the river. Up to now, you have seen the more identifiable features on the sectional chart. But your chart also has certain airspace information, which you can interpret only by careful study. As you learned earlier, all airspace is divided into two main classifications: uncontrolled and controlled. Uncontrolled, or Class G airspace, usually begins at the Earth's surface and extends upward to the base of the overlying controlled airspace. Class E controlled airspace is identified by tinted bands with the color dissolving into the area of controlled airspace. The height of the floor of this airspace is identified by different colors. A blue tinted band indicates the floor begins at 1,200 feet above the surface. A magenta tinted band indicates the floor starts at 700 feet above the surface. In some areas, the floor of Class E airspace may begin at altitudes other than 700 or 1,200 feet above the ground. These areas are indicated by overlapping blue lines. The floor of Class E airspace is depicted next to the line. In this example, the floor begins at 5,300 feet MSL. At some airports, dashed magenta lines indicate that Class E airspace begins at the surface. Another type of Class E airspace is a federal airway, commonly referred to as a Victor airway. The center line of an airway is marked in blue on sectional charts. Several other types of controlled airspace are also depicted on sectional charts. These include Class D airspace with its lateral limits appearing as blue dashed lines and its vertical limit indicated in hundreds of feet. If Class C airspace is designated at an airport, it will be shown like this. The solid magenta lines indicate the lateral limits of both the inner and outer circles. The extent of the outer area is not depicted on sectional charts. Class C vertical limits are shown in hundreds of feet MSL. The upper limit is printed over the lower limit or floor of the airspace. In this example, Wichita's outer circle has an upper limit of 5,300 feet MSL and a floor of 2,700 feet. The inner circle has the same upper limit, but the floor extends down to the surface. Class B airspace is outlined by solid blue lines, with the upper and lower altitude limits depicted within each sector. Class B airspace is also shown on VFR terminal area charts. The area covered is indicated on sectional charts by a wide blue line. If fixed-wing special VFR operations are prohibited, the term No SVFR will be included directly above the primary airport's information block. Other types of airspace you will find displayed on the chart are prohibited areas, restricted areas, military operations areas, and warning areas. In this discussion, we've talked about the major features of aeronautical charts. To get additional information, you will need to review the manual and the chart legend. Aeronautical charts are the basis for all air navigation. The time spent becoming familiar with them will be well worth your effort. The ability to quickly find chart information reduces your workload in the air, allowing you more time to devote to your flying.